Welcome to Adangal. Good evening to all.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening. So let us revise about interference and diffraction. Okay. And I will be discussing only PYQs from this section, apart from telling you the important formulae. Okay.
Okay, sir.
So now, first of all, when we superimpose two waves, then what is the resultant intensity at a point? And this is what happens in Young's double slit experiment. There are two sources. Okay. So there are two light waves. One is like this, other is like this. This one. Phi here, phi is the phase difference. The resultant intensity. Sin A cos B minus cos A sin B. Is it clear up to this point? And then we can get the resultant. Now. Noted?
Yes, sir. 1 minute, sir.
So you can put this over there, this over there.
Yes, sir.
Okay. So where A is equal to it was square. No? So this is the main formula for the intensity, resultant intensity at a point that we use. And I1 and I2 are the intensities due to individual sources that we are superimposing. Okay. So I max, for I max cos phi will be 1. So we can write it like, which is proportional to A1 plus A2 square. And I minimum cos phi will be minus 1. Okay. And for intensity to be maximum, path difference should be
N lambda.
And for minima, it should be or
N
even
plus 1 lambda. Lambda.
yes. And then there are questions which are quite famous on the intensity ratio in the interference pattern, which make use of this formula, A1 plus A2 whole square by A1 minus A2 whole square. So this formula is very important. Okay. Clear?
Yes, sir.
And then the another formula is regarding the position of maxima from central maxima or the minima from the central point. Na? But for that purpose, I need to make a diagram, which I will do on the next slide. So have you noted up to this part?
Yes, yes, sir.
Yes, sir.
Okay. So let us make the diagram. Okay. Distance between the slits is small d. Distance of the slits from the screen is capital D. So it means this is b by 2. This is b by 2, and let this distance is y. Of course, yn, depending upon whether it is nth maxima or minima. Okay. Clear?
Yes, sir.
So now for nth maxima, yn equal to n lambda d by d. For nth minima, okay, fringe width, which is denoted by beta, that is d by d lambda, and fringe widths of bright and dark fringe is same. Means all the fringes are of same thickness in the interference pattern, and all the maxima are equally bright, and similarly all the minima, they have same intensity, so there is no intensity difference. Clear?
Yes, sir.
So now what happens if we perform this double slit experiment in some kind of liquid? What will be the,
Clean to liquid.
yes, if Young's double slit experiment is okay, clear? So now what happens if we insert a slab in path of one of the rays? So this was the setup.
There will be a shift of fringes.
Okay, and towards which side? Any idea?
Toward the positive. If the slab is placed on the path 1, then it is shifted toward path 1.
You have to tell me about the maxima. Na? Central maxima. You are talking about central maxima.
Yes, sir. All the maxima shifted, not only central maxima.
Yeah, obviously all will get shifted.
It will be shifted upwards. The central maximum is shifted upwards in this case.
Sir, by mu minus 1 to t d by d.
Very good. Let its thickness is t. Okay. So shift is given by mu minus 1 t d by t. Number of fringes shifted. Shift over fringe width. So mu minus 1 t by lambda, na? Isn't it? Okay. Is it clear?
Yes, sir.
And the shift is towards the side in which the glass slab is placed. Na? The shift will be in the upward direction in this case. Am I right?
Yes, sir. Just by the case of central maximum, we can conclude.
And all the fringes, they will get shifted by the same amount, na? Because it is independent of the order of the fringe. Okay. And it is also, okay, let me write, all the fringes get shifted by the same amount. Okay, let me ask you one question. There are two sources. One is emitting blue light and other is emitting red light. So for which source the shift will be maximum?
Blue light.
Because of its wavelength.
Lambda is less, isn't it?
Less.
Yes, sir.
Anyone else?
The shift will be seen.
If the number of fringes.
This is
Yes,
independent of lambda. Okay, independent of lambda, shift will be same.
Okay, sir.
Only the fringe width will be different now for blue and red. That's why the number of fringes shifted will be more in one case. But the distance by which the pattern shifts, it will be same, whether it is blue or red. Okay, clear?
Okay, sir.
And then there were other problems that we discussed. Let me tell you about that also. Now there is a main slit also, na? Which we are not showing in this diagram, but let us make that main slit. Okay, so this is a point O. So earlier position of S is this, but now the main slit, you have shifted the main slit upwards, little bit upwards. Here, okay, means this distance and this distance is different. So in this case, the central maxima will shift downwards over here, O dash. Okay, Is it clear or not? Only then the path difference will be same. Na? Earlier this ray is traveling less, this is traveling more, so later this will travel more and this will travel less, and that can only happen if the maxima shifts downwards. Na? So if the main slit
Yes, sir.
and what is the shift? SS2 minus SS1 into capital D by D. Okay. Clear?
So can I go to the previous slide once? Yes, sir.
Now see. This distance is equal, okay? But now let me show you what is happening. This is some other medium.
So here mu1 is greater than mu2.
I have written that shift towards the side of denser medium. Means I am assuming that refractive index of this medium is greater than this medium, because I have shown that the central maxima it has shifted upwards. Means I am taking mu1 to be greater than mu2. But if you take mu2 to be greater than mu1, you will show the shift to be here downwards. Okay, clear? So then what will be total y for you? Earlier also we have written the position of nth maxima. So what do we have for nth maxima then? This is for the central maxima. It means we need to add this quantity into the formula for the position of nth maxima.
Lambda d by d.
Yes.
Yes, sir.
So for nth maxima, we have okay. So what does this mean? It means all the fringes, they will be shifted. Clear? Clear to all?
Yes, sir.
So these were the possible questions that can be asked on interference. Means theory part. Obviously, we will be discussing the numericals. And the last one is interference in thin films. Colors in thin films. This is I, then this is also I. And then this undergoes refraction. It comes here, then undergoes PIR, then goes out, and these two interfere. And then there is a perpendicular from here. Okay, this is reflected ray 1, this is reflected ray 2. So this angle will also be I. And these both angles are R. Okay, so this is the thickness, this is mu, this is air. And then there is a transmitted ray like this, T1. And there is interference in transmitted system also. If this ray also comes like this. Okay, but that we are not studying. Reflected and transmitted system are complementary. Okay, diagram is clear. So we only require T, R, and mu. Okay. So in this case, for constructive interference, we have two mu T cos and lambda. Please check. Clear? Done?
Yes, sir.
Let us discuss some numerical problems. Try to solve this one. Very good, Durga. It's wrong away. Very good, Sanjumati. It's wrong, Ritika. What about others? I'm waiting. Very good, Samruti Shri. Okay. What is the formula for max intensity? Whole square, na? Am I right?
Yes, sir.
Sir, B.
1 minute, 1 minute. Okay. So root I1 plus root I2. Should I move in this manner or? Yeah, I think that this will be okay. Yes, answer is B. I'm assuming I1 to be higher than I2. So now if you add 1 and 2, 2 root I1 is 4 root I0. Root I1 is 2 root I0. So I1 is 4 I0. Na? Okay. And if you subtract 2 from 1, isn't it the easiest and the shortcut one? Okay. Clear?
Yes.
We have other ways also, in fact, but this is the shortcut one. Done, everyone?
Yes.
Next one. Very good, Durga. Very good, Arun. See, we have to get I maximum because all the maxima they are equally bright, na? This is the answer. Clear? Please spell.
Yes, sir.
Yes, sir.
Yes. No, Durga. Very good, Arun. Samruti Shri, it's wrong. So now we need this fringe to be dark. Okay. So earlier this is bright. Now we want it to be dark. So it means the phase difference should be pi, or the path difference should be lambda by 2. Na?
Yes, sir.
So path difference introduced by this glass slab. No? This is glass slab. Yes. So it means path difference introduced by the glass slab must be equal to lambda by 2. For central fringe to be dark, the path difference, minimum path difference, not the path difference, minimum path difference between the rays from should be lambda by 2. Now we know that for minimum path difference, P will be minimum, na? Because mu is constant. Please check. Please check, everyone. Done or not?
Done, sir.
So then let us discuss about diffraction. Rather than going towards the red line, it moves towards the blue one. Means this part is also illuminated by the light. Means it bends around the corners of the obstacle. Okay. This bending. This is called diffraction. And this occurs for all kind of waves, and this is readily observable in for sound waves. Okay, because the wavelength of the sound waves, it is comparable to the walls and the windows that we have at our home, office, etc. So that's why we can hear the voice of the person that is on the other side of the wall. Okay.
Yes, sir.
Clear?
Yes, sir.
So what is the condition then? Diffraction maxima, minima, and who will tell me?
D sin theta is equal to n number of minima.
D sin theta. Okay, this is D.
Sir.
Okay, then this is capital D.
Yes, sir.
Okay. And for minima, you are saying D sin theta equal to n lambda. This is for minima. Very good. And what can be the minimum value of n over here? Can it be
1.
Yes. N starts from 1. That is also the important part. And then for maxima, what do you have for maxima? Can you write sin theta n over here? Because you are saying nth minima. Isn't it? For nth minima, that will be good. Nth secondary minima rather. That is the complete sentence. So for nth secondary maxima, because in the center obviously we will have one maxima. Okay, so what do we have now? D sin theta n dash. If you write 2n plus 1 lambda by 2, then it is like this. And then what is width of central maxima? Width of central maxima. 2d lambda by d. Okay. Clear?
Yes, sir.
And now, if you write sin theta from here, actually what you can do over here is, and if you equate this yn by d to the value of sin theta, you will end up getting the distance of the nth secondary maxima or nth secondary minima from the central right fringe. Okay. So yn by d, it will be n lambda by d for secondary minima. Let me write. Please check. And you can also get the angular position by this formula. Okay. Sin theta n is n lambda by d, and for small theta, theta n is sin theta n. So you can also get the angular position. Am I right?
Yes, sir.
And what about the intensity at the maxima and minima? Anyone? Intensity is different, na? Central maxima is bright one, and then the intensity it goes on decreasing for all the secondary maxima depending upon the order. More is the order, lesser will be the intensity. Okay.
Yes, sir.
Yes, sir.
Okay. So now there is a diffraction grating also. Na? diffraction grating in which they ask you about the absent spectra. You might have studied.
Yes, sir. Simultaneous of interference and diffraction cases.
Yes. So I can write straight away, I think. This is the absent spectra in case of absent spectra is that when
Interference maxima, diffraction minima.
yes, minima and interference maxima is there. It means the final answer is this. If B is equal to A, okay. Clear?
Yes, sir.
Yes, sir.
And then there are questions on anti-reflection coating. Let me discuss that question. And anti-reflection. Thickness of anti-reflection film coating is given by lambda by 4 mu. Lambda is the wavelength. Thickness is 1.25. Okay, such a small portion is this, and this is for normal incidence.
So for oblique incidence, there is no such formula.
Of course, the formula is there, but that is not in your syllabus.
Okay, sir.
Very good, Rita. Very quick to answer. Fourth order.
line में तो हो गया.
Yes. Clearly given that fourth order is missing. Yes, Durga. So you can make use of this formula.
Yes, sir. Reply.
It means A plus B by A is 4. That's it. Such an easy question. Clear?
Yes, sir.
And a lot of them are diagrammatical questions, so it is not possible for me to make the diagrams. Okay, let me write the question and then I will tell you which order is given. That will be good. Intensity versus this is the question. Yes, Durga. So here is the minima. See, here is the minima. Am I right?
Yes,
So
sir.
which order is this? This is 0, 1, 2, 3, 4. So one peak is missing. There should have been one peak. So fifth one is missing. Okay. Is it clear from the diagram? No,
Yes.
Mira, it's wrong. So it means fifth order is missing. So a plus b by a is equal to 5. Okay. From the diagram, it is clear that fifth order is missing. So b is equal to 4a. So width of each of the slits is 0.7. So no need to write b actually. Here we can do. It was micro. So it is 3.5. So this is the separation between the slits. A plus b. Okay. Clear? Please tell.
Yes, sir.
Yes, sir.
Yes, sir.
So that's all for today. So tomorrow we will again discuss some problems and rest of the part. Okay. So tomorrow this optics will get finished. Okay, students. Bye bye. Take care.
Thank you.
Thank you, sir.
Thank you,